Hi guys, welcome back to the channel. In this video we are going to discuss the basics of flip-flops and latches. So we are going to discuss both of the basic block diagrams and with the help of timing diagram analysis. So let's get started. So if you observe in the previous video we have discussed these all things. So this is the basic block diagram of any synchronous sequential circuit. So if you observe we have a memory element over there. For that memory element we are going to use the latches and flip-flops. So these two are basically the memory elements. It can store a one bit of information whether 0 or 1, and it helps when we require the feedbacks in the combination for the combination circuits. For whole sequential circuits that memory part is very important. So if you combinedly used in the sequential circuits, the memory elements is two types, that is latches and flip-flops. So these two are used majorly in the sequential circuits for the memory elements purpose. So if you observe, these can store only one bit of information. Already we have known that. So let's just starting with the latches. So if you observe, latch is nothing but memory element. So whatever we send, that stores and again it reflects in the output. So if input is 0, that reflects in the output same as it is because it is a memory. So output also would be 0. So if input is 1, output would be 1. So that is the main thing of memory we know already. So as this is immediately responding, so this can also be classified as asynchronous sequential memory element. Means this is immediately responds to the input level changes. So that is known as transparent latch. So as this is immediately responding, we don't want this normal transparent latch because so we need discrete levels changes. Because if it is immediately changing, how we can change or modify or according to our requirements. So we majorly not use this transparent latch. So we have another kind of latch called the gated latch. So let's see the gated latch also, the block diagram. So this is the basic block diagram of gated latch. So if you see this, so we have total input, output, and again with this an additional thing called enable. So enable acts here as a clock. So we have to pass in the enable as a clock pulse so that it can have some triggering, so that it behaves as a gated latch. So it will not respond immediately to the input levels, so that we can manipulate the clock signals or input signals. So we can also manipulate the output signals with respect to input signals, so that we are going to use the enable line for the gated latch. So I already discussing about this only. So in the enable line we are going to pass the clock signal. So this is synchronous sequential memory elements, we can say the gated latch, because the synchronous sequential circuits means it will respond to inputs only at discrete time intervals. So we are only waiting for that only. So we will see how output will be influenced with the help of clock signal and how it will relate to the input signal. So let's get started with the timing diagram analysis and understand the clock signals. So startingly we are going to pass a clock signal, that is in the enable line. Then we are going to pass the input pulse in the input line. Then we are going to compare the clock and input so that we are able to judge about the output signals. So the latches are basically level triggered. So already we have discussed what is meant by level triggering or edge triggering. So the gated latch is level triggering. So if you see the clock and input signal, so it is not just directly matching because it might be any of the thing. So clock is just normal thing, I took random, and input is I took some random thing. So as this is the level triggering, when clock is high only, the input is corresponding to the output, it will respond. So I have took each and every position, the lines also, the dotted lines also at each and every level. After every level changes, if you observe the first level, that is changing from 1 to 0, then again the level changes from 0 to 1, like that is going. So every level changes, I took a dotted line so that you can able to understand and relate or compare the clock and input signals. So we have to compare both of them and we have to produce the output. So now here we have got a comparison. So if you compare the input and clock, so when the clock is high only, it will follow the input, otherwise the input or the corresponding output would be 0. So if you observe clearly, you have to observe clearly, the input and output would definitely be the same thing, but a small change. If clock is high only, the output would be same according to the input, otherwise the output would follow the high. So for the output we have to compare the clock and input. So if you compare them, you can observe that first the clock is high, so the input will be remain same. Then also you can also observe that clock is high for the next pulse. So it is again going to follow the input level. So if you observe clearly, you can relate both of them. So if you want to more visualized about that clock pulses on the relation between them, so you can also observe here. I have separated as a groups. So if you observe the clock input and output at a time, so you can also observe that. So when clock is high, you can see the input is following the same way, in the same fashion the output is also there. So in the next one, if you see the clock is high, so in between we have clock is low. In that the input is not following the output. So output is just the low signal. So from that you can also observe that. So the input based clock will be producing the output. I hope you can understand and relate between all of these segments. So now let's discuss about flip-flops. So we have understood the latches. So in the latches we have two types. So transparent latch and gated latch. Out of both of them we are required only with the gated latch because that is very important. So if you also observe, the flip-flops is very much similar to the gated latch because here we have input output again with that not is this is enable line. So we have directly the clock signal over here. But a small change in the latches, in the gated latch we are used with the level triggered, but in the flip-flops we are going to use the edge triggering. So if you also observe what is meant by edge triggering, so when the rising edge or the falling edge is no, we are going to compare this the clock pulse. This is the clock pulses. The clock pulses has to be compared with the inputs and we are going to produce the outputs. So the rising edge are also known as positive edge triggering. The falling edge is also known as negative edge triggering. So let's get started with the positive edge triggering. An example. So the same example I will take. So if you observe clearly, I have took the same example, but the clock signals is not responding to the levels, but it is in this case we are going to follow the edge triggering. First I took the positive edge triggering, means the left side it will be high, means when, so you can also clearly observe over there I have took the dotted lines also according to the rising edge only, not here levels. Each and every level I did not took the dotted lines for the representation purpose. So you have to compare the clock and input and we are going to have the output signal. When the clock signal is high only, we are going to compare the clock and input and we are going to produce output. So this is the output timing diagram. If you observe clearly, in this we are going to follow the clock when it is the rising edge. So first you can observe the all the way output is 0 when the first rising edge is coming. So if you observe the input, that is high only. So we are going to have the output high. Then you are going to see the next rising edge in the clock. That is in the second pulse we have. So the input, if you compare in the same line, the input is high. So we have the high in the output. So if you compare the third rising edge, that is if you compare input also, that is high, again high. So we are going to have the output again high. So in the fourth rising edge, we are going to have the input is low. So again in that we are going to have the low pulse in the output. So that we are going to compare the clock and input and we are going to produce the output. I hope you understood this. So if you don't understand even, you can also observe or relate with this here. So at the same time clock input and output you are going to observe so that you can get a relation. When the rising edge, according to that we are going to follow the input to produce the output. So input is rising, so output is also rising there, means high level we can say. Simply compare all of them and we are going to have the fourth clock pulse. Near fourth clock pulse we are going to have the clock pulse is, means the edge is high but the input is low, so that you are going to have the output is low. So the next thing we are going to see with the help of the negative edge triggering. So we have already seen the positive edge triggering. So the same diagram I have took, the same clock pulse and the same inputs I took for the negative edge triggering also. Let's see how to build this output circuit diagram, output timing diagram analysis. So if you see clearly over here, for the output purpose we are going to respond the clock pulse with the help of the input. So the first falling edge is in the first pulse. In that if you observe the input is low, so we are going to have the low. So the next in the next clock pulse we are going to have the next falling edge. So in that also the input is low, so next output will be also low. So in the next third falling edge we are having the falling edge, but the input is also low there, so we are going to have the low. So the fourth falling edge contains the input is high, so their output would be high. I hope you can relate with the rising edge. So if you observe clearly, we have some relation or likelihood of the flip-flops and the gated latch are somewhat similar. So we are going to have the flip-flops with the help of the gated latch also, because in the gated latch we have enable, but in the flip-flop we have clock. So in the place of enable we are going to have the clock transition circuit. So that makes the whole one as flip-flops. So we can construct the flip-flops with the help of the gated latch also. So majorly we can have we have to know that latches and flip-flops ultimately are made up of logic gates. So in the upcoming video we are going to see in detail about the latches, how to make the circuit diagram of latches with the SR latch with the help of the NOR gates and NAND gates. We are going to see in the individual videos. So stay tuned for the upcoming video, because ultimately all are made up of logic gates, but latches and their circuit diagrams are very important for the memory elements. We will also cover the truth tables and circuit diagrams in the upcoming video. I hope you understood this video. Thanks for watching up to now.